Hello, precious one. I welcome you once again to Kenya Mathematics Classroom. We are still looking at calculus, and today we are going to look at the general rule for differentiation. In our previous video, we were looking at differentiation from the first principle, and now we are looking at the general rule for differentiation. Now, we are looking at the general rule for differentiation. That's the general rule. So, let's assume that you are given the function that is y equals ax exponent n, or when you are given y equals ax exponent n, it can also be written as f of x equals ax exponent n. So either it is y equals ax exponent n or f of x equals ax exponent n. Now, if you have y equals ax exponent n, a is the coefficient of the variable, x is the variable, and n is the exponent. And so when you are differentiating, you say dy dx, this will be equal to, you multiply the exponent by the coefficient of the variable. So n times a will give us na, then you write the variable, then you subtract 1 from the exponent, that is n minus 1. So that is the general rule for differentiation. So n minus 1. Now if the function is f of x, then we, instead of dy dx, you write f prime of x, and this is equal to the same approach. N times a will give us na, then your variable is x, then you subtract 1 from the exponent, so you have n minus 1. So that's the general rule for differentiation. Now let's assume that we are given f of x to be equal to x squared. We have f of x to be equal to s cubed. Then we have f of x to be equal to x exponent 4. Then we have f of x to be equal to, we have x squared plus 2x. If you remember, when we were looking at differentiation from the first principle, these are the same examples we used. So if you have f of x equals x squared, and you have to differentiate with respect to x, this time around it is not from the first principle, so we are not going to use the first principle formula, but we have to differentiate with respect to x. So the first one is f of x equals x squared. Take note that the coefficient of the variable here is 1, but 1x is the same x, and that's why it cannot be seen. So the general rule says that you multiply the exponent by the coefficient. So 2 times 1 will give us 2 times 1, so f prime of x, that's we are differentiating. 2 times 1 will give us 2, then we have our x here, then we subtract 1 from the exponent, and this should be 2x, 2 minus 1 is 1, and x raised to the power 1 is the same x, so we have 2x. If you remember, when we differentiated from the first principle, f of x equals x squared, we have 2x. And so every time you can use the general rule to find out whether what you are getting is correct or not. So let's look at the second one. F of x equals s cubed. So when we say f prime of x, this will be equal to, the coefficient of the variable here is also 1. So 3 times 1 will give us 3 here. Then we have x, then we subtract 1 from the 3. And this should be 3x, 3 minus 1 is 2. So we have 3x squared. You can also compare with the answer we have from the first principle. We have 3x squared. Now we look at the third one. We have f of x to be equal to x exponent 4. So when we say f prime, because we are differentiating, f prime of x, this should be equal to, the coefficient of the variable here is 1, so 4 times 1 is also 4, we have x, then we subtract 1 from the exponent, and that will give us 3. So 4x exponent 3. So when you differentiate with respect to x, hence raised to the power 4, we are getting 4x exponent 3. Now when we look at the fourth one, that is f of x is equal to, we have x squared plus 2x. So when we say f prime of x, now we multiply the exponent by the coefficient. So 2 times 1 will give us 2x, subtract 1 from the 2 will give us 1. So it's no more there again. Then plus this, take note that 2x, this x is exponent 1, but x raised to the power 1 is the same as x. That's why the 1 cannot be seen. So the exponent is 1. So 1 times 2 will give us 2. Then we have x, then we subtract 1 from the exponent. And this will give us, here we have 2x, then plus, here we have 2x, 1 minus 1 is 0. Then x raised to the power 0 is 1. and 1 times 2 is 2. So here we are going to have 2x plus 2. So if you remember, when you refer to the answer we had when we were differentiating from the first principle, x squared plus 2x, we have 2x plus 2. So in general, that is how we differentiate with respect to x. So take note of that. In general, that is how we differentiate with respect to x. In general, that's how we differentiate with respect to x. So let's take some few examples. Let's assume that we are rather given y equals, you have 4x exponent 3 to differentiate. Now, if you are given 4x exponent 3 to differentiate, because the function is y equals, then differentiate, instead of writing f prime of x, we rather write dy dx. It's the same as f prime of x. But when the function is given in terms of f, then it means you use f prime of x. But if it's given in terms of y, then use dy dx. So dy dx is the differentiation. That means you are differentiating y with respect to x. Now, you know that the coefficient of the variable is 4. Then the x is the variable and the exponent is 3. So the general rule says that you multiply the exponent by the coefficient. So 3 times 4 will give us 12 here. Then our variable is still x. Subtract 1 from the 3, we are getting 2. So the answer is 12x squared. The answer is 12x squared. Okay, let's still consider if you have y equals 2x exponent minus 3. Then dy dx will be equal to, so the exponent is minus 3, the coefficient is 2. So minus 3 times 2 will give us minus 6. We have x here. When you subtract 1 from 3, minus 3 minus 1 will give us minus 4. So we are going to have minus 4 up here. So take note of that, it's very important. So minus 3 times 2 will give us minus 6. Then we have our variable x here. Then we subtract 1 from the minus 3 and that will give us minus 4. So it's minus 6x exponent minus 4. And this can be written as minus 6 over x exponent 4. That is when we bring the x exponent minus 4 down, according to indices, the negative exponent will change to positive exponent. If it goes up, it still becomes the same thing again. So in general, that is how we differentiate functions. In general, that is how we differentiate functions. So you use the exponent to multiply the coefficient of the variable, then you subtract 1 from the exponent. Then you subtract 1 from the exponent. Now we can have examples. If you have 2x3, then you can have 3x2, then we can have 7x. When we have to find dy dx, this will be equal to 3 times 2 is 6. We have x. Subtract 1 from here, we have 2 plus the next one. 2 times 3 is also 6. X. Subtract 1 from here, you have 1 plus, don't forget, this exponent 1. So 1 times 7 is 7x. Then you subtract 1 from this. And this will be equal to, you have 6x squared. Then you have 6x because x exponent 1 is the same x. Then you have 7x. 1 minus 1 will give us 0 here. So a step down, this is 6x squared. We have 6x and this is plus 7 because x raised to the power 0 is 1. And 1 times 7 is equal to 7. Now, let's assume that you are giving y is equal to 4 to differentiate with respect to x. You see that y equals 4, what we have is 4, it's a constant. But if you ask to differentiate y with respect to x, this can be expressed as, this is the same as 4x exponent 0. Because x raised to the power 0 is 1, and 1 times 4, you are still getting the same 4 again. You only want to attach x, that's all. So if 4 is the same as 4x exponent 0, and we are differentiating that function, then we multiply the exponent by the constant coefficient. So 0 times 4 will give us 0. Then we have x. Then we subtract 1 from the exponent. And 0 times anything is 0. So that means that when you differentiate a constant, it's equal to 0. So any constant you differentiate, you are getting 0. Take note of that. Later, I will show you how to use the first principle formula to prove that differentiation of a constant is equal to 0. So take note of that. Anytime you are differentiating a constant, you are getting 0. So this is the general rule for differentiation. This is the general rule for differentiation. This is the general rule for differentiation. Now we are going to look at what we call the product rule, and we also look at what we call the quotient rule. Now when we say product, what comes to the head is multiplication. And when you say quotient, what comes to the head is also division. And so we are going to look at what we call the product rule and what we call the quotient rule. What makes it quotient and what makes it product. Now, assuming that, so we have what we call the product rule. Now if you have y equals uv, if you have y equals uv, u is a function and v is a function, and so when you write uv, it means the two functions are multiplying. And if the two functions are multiplying and you are supposed to differentiate y with respect to x, from the product rule we have u, you hold u constant, then you differentiate v with respect to x. When you are done, plus you hold v constant, then you differentiate u with respect to x. So this is what we call the product rule. This is what we call the product rule. So if you have y equals uv, that is two functions multiplying, then you keep u constant, then you differentiate v with respect to x, plus you keep v constant, then you differentiate u with respect to x. Now let's look at this example. Let's assume we have y equals, we have x squared plus 2x here, then we have 3x cubed plus 7 here, and we are asked to find dy dx. So if you have to find dy dx here, then you see that these are two different functions multiplying. So the first method of solving is to expand. When you are done with the expansion, then you now differentiate it term by term. You will get the same answer. But because the two functions are multiplying, then we are going to use the quotient rule to expand, to differentiate. Now, if you have y equals, we have x squared plus 2x, then we have 3x cubed plus 7. Now this is u and this is v. Now from the quotient, the product rule, we have dy dx. You hold u constant, then you differentiate v with respect to x, then you hold v constant and differentiate u with respect to x. And so our dy dx here will be equal to u, we hold u constant, and u, the function is x squared plus 2x. So x squared plus 2x, hold it constant, but differentiate v. Now, this is the v function. When we differentiate v, take note, now we know the general rule for differentiation. So 3 times 3 is 9, then you have x, then subtract 1 from the 3, you get 2. So this will give us 9x squared. Then plus, when you differentiate a constant, you know it's 0, so we are done with that. Then hold v constant. And when you hold v constant, v is the function 3x cubed plus 7. So we have 3x cubed plus 7. Then you differentiate u with respect to x, and this is the u function. When you differentiate this will give you 2x plus 2. So you have 2x plus 2. And I guess you know why this is giving you 2x plus 2. This is a general rule. So the coefficient here is 1. 2 times 1 is 2. Then x, subtract 1 from this, then you are getting 1. And s raised to the power 1 is the same thing. So when you differentiate 2x here, you're also getting 2. So you can try that and see that you are getting 2x plus 2. So that's what you do. So you keep the u constant, then you differentiate v, then plus you hold v constant, then you differentiate this one, then you simplify. So now our dy dx here will be equal to, now this is simple expansion, so we can expand. In most cases you can leave it like this, but let's try to expand. So we have x squared times 9x squared. And according to indices, this will be 9x exponent 4. When you refer to my presentation on indices, you will know the reason why we are getting this as the answer. Plus, and you have 2x times 9x squared, and that will be 18x cubed. Then plus, now we have 3x cubed times 2x, and that will give us 6x exponent 4. Then 3x cubed times this will give us 6x exponent 3. Then 7 times 2x will give us 14x. Then 7 times 2 will give us 14. So now we have dy dx here. We now simplify. You group the terms. So the x exponent 4 terms, we have 9 here, we have 6 here. 9 plus 6 give us 15. So we have 15 x exponent 4. Then the cube term, we have 18 and 6. So we have 18 plus 6, and that will give us 24 x exponent 3. Then the square term, there is no square term, but there is an x term. The only x term is 14x here, and the only constant we have is also 14. So dy dx will be equal to this. So that's how we apply the product rule to solve problems like that. That's how we apply the product rule to solve problems like that. Now, what I'm going to do is we are going to expand the question that we were given. Now, let's try to expand the question we were given and differentiate with respect to x term by term and see whether we are getting the same thing that the product rule is giving us. So the question was y equals, we have x squared plus 2x, then we have 3x cubed plus 7. So expansion, let's try to expand. X squared times 3x cubed will give us 3x exponent 5. Then x squared times 7, this will give us 7x squared. Then 2x times 3x cubed will give us 6x exponent 4. Then 2x times 7 will give us 14x. When you refer to my presentation on indices, you understand. Because if you have numbers of variables of the same basis multiplying, according to the first law of indices, when you keep one of the basis constant, what you do is to add the exponents. That's what I'm doing. So now we try to, after expansion, we try to differentiate y with respect to s. And now we know how to differentiate. So 3x exponent 5, 5 times 3 will give us 15. So we have 15x, subtract 1 from 5, we have 4. Then 2 times 7 will give us 14x. When you subtract 1 from 2, we have 1, and it's the same as x. Then we have 4 times 6, and that will give us 24. So 24x, subtract 1 from 4, we are getting 3. And when you difference this exponent 1, so 1 times 14 is 14. Then we have x. 1 minus 1 will give us 0. S raised to the power 0 is 1, so we are left with 14. We are left with 14. So when you compare this, you see that we have 15x exponent 4, we have 24x exponent 3, we have 14x, and we still have 14. So that you are getting the same thing. So it's either you expand and differentiate term by term, or you use the product rule to solve for that. Now, if you are asked to use the product rule, that means you need to use the formula. But if you are not asked to use the product rule, but you are rather asked to differentiate, then you can either choose to expand and differentiate term by term, or use the product rule to solve, and you get the same answer. So that is what we mean by the product rule thing. That's what we mean by the product rule thing. So now we are also going to look at very soon the quotient rule, what the quotient rule is all about. Then we will see how best we can solve problems on the product rule and the quotient rule. So in general, that will be that. Now let's look at the quotient rule. So with the product rule, when you have functions multiplying, then that is how you are supposed to solve it. So now let's look at what we call the quotient rule. The quotient rule. Now the quotient rule, if you have y equals u over v. So do you see that now the u is not multiplying the v, it's rather u divided by v. So this is a function, another function. So if you have function behaving like that, then if you have to find dy dx according to the quotient rule, you hold v constant. Then you differentiate u with respect to x minus hold u constant. Then differentiate v with respect to x. When you are done, you divide by the square of the v. That's what the quotient rule is saying. That's all. So this is what we call the quotient rule. Dy dx is v constant, differentiate u with respect to x minus u constant. You differentiate v with respect to x. When you are done, you divide everything you are getting by the square of the v. So let's assume that we have y equals, we have x squared plus 2x all by, then we have x plus 2. If let's say we have x cubed plus 2, this is what we are given, and this is quotient. You can see that we have one function dividing the other. So when we say we should find dy dx, then quickly write the quotient rule: v du dx minus u dv dx all by the square of v. So we have dy dx is equal to hold v constant. And this is your u and this is your v. So hold v constant. So we hold s cube as s cube plus 2 constant. Then we differentiate u with respect to s. When you differentiate u, we have 2x plus 2. So we have 2x plus 2. You take your time to do it. Then hold u constant. We hold u constant and u is s squared plus 2x. That is x squared plus 2x. Then we differentiate v. When we differentiate v, we have 3s squared, and this will give us, it's a constant, so differentiation of this will give us 0. So we have 3s squared here. So we have 3s squared here. All divided by the square of v, and v is the function s cubed plus 2. So we have s cubed plus 2, then we square. Then we simplify the numerator, and that one we need to expand. So s cubed times 2x will give us 2x exponent 4. Then s cubed times 2 will give us 2x exponent 3. Then 2 times 2x will give us 4x. Then 2 times 2 will give us 4. Then we need to also simplify this. Now s squared times 3s squared will give us 3x exponent 4. Then 2x times 3s squared will give us 6 exponent 3. All divided by s cubed plus 2 all squared. So a step down, dy dx will be equal to, now we have 2x exponent 4 plus 2x exponent 3 plus 4x plus 4 minus, that's you open the bracket, you have minus 3x exponent 4, and this will also be minus 6x exponent 3, all divided by s cubed plus 2 all squared. So we try to simplify the fourth term, s exponent 4 term, we have 2x exponent 4 minus 3x exponent 4, and that will give us minus x exponent 4. Then the cube term, we have 2s cubed minus 6s cubed, and that will give us minus 4s cubed. Then the square term, there is no square term. Then we look at the x term. The x term we have is plus 4x. Do you have any constant? Yes, there is a constant. The constant is plus 4. Plus 4. All divided by, take note, it is s cubed plus 2 all squared. You can decide not to expand the denominator, leave it. And so your answer will be equal to dy dx equals that. So that is how we also apply the quotient rule to solve problems like that. So that's the difference. For the product rule, when the functions are multiplying. For the quotient rule, when the functions are dividing, then we know which one to use. So in general, we'll be solving a lot of questions on product rule and quotient rule so that you get to understand this better. But for now, that will be all for now on this particular episode. Thank you.